ingredient in the mortar that masons use to lay brick and stone. Cement also goes into soil cement, a material that's used in paving roads, building dams, and lining reservoirs. The action begins at the limestone quarry. The limestone near the surface has a high content of the minerals silica, iron, and aluminum oxide. Deeper down, the limestone is more pure, containing less of those minerals and more calcium carbonate. The plant uses both types of rock, altering the proportions to make different types of cement. Workers drill holes in the rock wall in which they plant powerful explosives. For safety, the workers have to position themselves behind the area they're blasting, maintaining a distance of at least 50 meters. After the explosion, loaders move in. They transfer the limestone rocks to 50-ton capacity dump trucks. The trucks then haul their cargo to the cement plant nearby. At the plant, the trucks dump the rocks into what's called the primary crusher. The rocks can be as big as a piano. The primary crusher reduces them to about the size of softballs. There's a constant spray of water to keep the dust from billowing up and settling on the chutes. From there, a conveyor transports the rocks to the secondary crusher. It reduces them further to about the size of golf balls. Rock high in calcium carbonate and rock low in calcium carbonate are crushed separately. Now it's time to mix the two. The ratio varies according to the type of cement they're making. This overhead machine called a tripper makes piles of the required proportions. They call this the raw mix. Then a reclaimer loads the raw mix into a grinding machine called a roller mill. Depending on what minerals are already naturally in the crushed rock, the factory adds extra minerals such as silica and iron. Certain types of cement also require aluminum oxide. The roller mixes and grinds the ingredients uniformly, producing a dry rock powder called the raw meal. Now the powder goes into a preheater. The temperature of the powder is 80 degrees Celsius upon entering. Within 40 seconds, it gets more than 10 times hotter. This begins the process of bonding the minerals together so that they'll later harden when hydrated with water. The preheater is equipped with what's called a flash calciner. In about 5 seconds, it removes 95% of the carbon dioxide in the powder through a chemical reaction. This isolates the lime, which is the most important element in cement. From there, the powder moves into a rotary kiln, a huge cylindrical furnace. It's set at an angle so that the powder moves from top to bottom a distance of 49 meters. The kiln rotates about 2 turns a minute to ensure the material travels through at the right speed. The burner's gas flame at the bottom reaches a scorching 16 to 1700 degrees Celsius. As the powder approaching it reaches the 1500 degree mark, it fuses into pieces about the size of marbles. These pieces are called clinker. As the clinker leaves the kiln, large fans cool it down to between 60 and 80 degrees Celsius. It's important to cool the clinker quickly in order to have quality cement. From here, the clinker goes to the storage area. The last stage of cement making is called finish grinding. They add some gypsum to the clinker. The precise amount varies with the type of cement they're making. Gypsum delays the cement's setting time so that it can be worked for up to 2 hours before hardening. The cement mills are called ball mills because they contain metal balls, about 150 tons of them in the largest mill. As the mill rotates, the balls crush and grind the clinker and gypsum